this idea of a limit. Okay. Now, it is important that you understand that the function does not have to be defined at, for this example, doesn't have to be defined at 1. And I'll give you an example here in a minute that maybe, Ryan, wake up, okay, where the function doesn't have to be defined. Okay. Okay, second example. We're going to do a whole bunch of examples, okay? So your function is fx equals 4 if x is not equal to 3, and fx equals 0 if x is equal to 3. Okay? What is this kind of a function called? Anybody remember? What is this kind of function called? Nice. Who's that? Nice, Dia. Piecewise. Yes. Okay? So the way you graph this is you've got this line here, and then you've got a closed circle here because of this, because of that. Okay? So the closed circle means that when x is equal to 3, f is equal to 0. That's what this means. Right? The function value is 0 at that point. Okay, let's go answer this question here. Let's go answer that question here. Okay? Here's my x equals 3. Here's my x equals 3. Okay? So I'm going to go along my function. Is x getting closer and closer to 3? Is it? Hello, I'm asking a question. Yes. What is the function getting to? What number is the function approaching? This is 1 per box. Sorry? 4. Right? Because remember, function means the y value. What is the y value here? 4. What's the y value here? And so on. Until, so you can see that the function is staying flat, and it's a 4 all the way through. Coming in the other direction. Coming in the other direction. What's the function value approaching? 4 as well. Are these both the same? I.e. unique, only one of a kind. So then this answer would be 4. Okay, that answer would be 4. Now notice that I'm not asking you what is f of 3. That's not what I'm asking you. Because if I ask you this question, then what would you tell me the answer was? 0. Right here. You can see it right there. It's also right there. Okay? So notice that these two are not the same thing, and they don't have to be. They don't have to be. All right? You guys with me on this? Okay? We can take this a step further and change this so that you would get f of x is undefined if x is equal to 3. Then instead of a closed circle here, it would be an open circle. Saying that there's a hole there. Okay? It's not defined. The limit would still be the same. The limit would still be the same, because remember what you are trying to do. You are answering the question, is the function approaching one number from both sides? And it's approaching the same number, whether this is closed or open, doesn't matter. Okay? So again, this means that, Sina, are you here? Oh my God, you can't sleep in front of my nose, like right there. Okay? Edwin, wake up. What you guys been doing, man? Sleeping at 3 in the morning? 2 o'clock? Being on Booking Face?
No.
Yeah, you don't Facebook, you book Face.
No, I'm on Gmail.
Oh, okay. Alright, you guys get the limit concept now. Okay, Ryan, we're going to be doing several examples, and if you stay awake and stay with me, you'll get it. Okay, you guys answer this question now. So here's what you are talking about, Krakow. So here you've got f of x equals x plus 2 when x is less than or equal to 0, and it's equal to minus x plus 4 when x is greater than 0. So this is the situation you are talking about. Okay?
No, she was not paid to do this.
She was what?
She was not paid to
She was, I don't know, Krakow. Did I pay you to ask this question? This wasn't a plant, right? I didn't pay you, yeah. So let's go do our thingy, okay? So we're going to go along the graph, and is x approaching 0 as I go along this graph? Yes? In this case, what's the y value approaching? This is 1 per box, it's approaching 4. Nice, Anna. And then I have to go on the other side. Okay? Sorry? If I'm going along on the other side, is x approaching 0? Then what's the y value approaching? Is this unique, one of a kind? No. So then the answer to this is does not exist. D&E does not exist. All right, you guys with me on that? Did you see that in the SAT book? In where? Oh, Mean Girls. Oh. Okay, so Krakow, does that answer your question? Okay. Yeah. Sorry? Okay, one more time. Let's go over it. Shh, shh, shh. Remember what we are trying to do, okay? We are going along the function. So, Maria, you want to look here and then take notes, okay? So, you're going along the function, and as you are going along, is x becoming closer and closer to 0? Remember, here's 0 for x, okay? So, is x becoming closer and closer to 0? Is it? That's what this is saying. That's what that is saying. Okay? And when x is getting closer and closer to 0, what's the y value of the function? 4. Whoa! What happened there? So this is a 4. And then if I go on the other side, doing the same thing, is the x value getting closer and closer to 0? And the y value gets to 2. See, the key word that we want to really exploit, and maybe this is the reason why it was Mean Girls. Unique. The word unique. One of a kind. One number. Okay? So if you, oh my God, in the middle of this exciting lecture here, you want to go pee? Jeez.
You know how much Arizona I had today?
Well, not my fault. Okay, let me just finish this, okay? So then you can see that this is not unique. It's not one number. And therefore, the limit does not exist. Okay, question?
So, does this apply to all non-connected segments?
Yes.
All DNA?
Yes. Yes. All right, yeah, Shannon, you better go. Okay, I don't want to mess in my class here.
Okay. By the way, was that recorded?
Probably did. Okay, how about this one here? So this one here, let me just write down the function for you. F of x equals 1 over x squared.